The variable complex number z is given by z equals to 1 plus cos 2 theta plus I sine 2 theta, where theta takes all the values in the interval negative half pi to positive half pi. Show that the modulus of z is 2 cos theta and the argument of z is theta. Okay, and then next is proof that the real part of 1 over z is constant. Okay, first of all, okay, you have cos 2 theta and sine 2 theta, so looks like we need the double angle formula, so which is 2 sine theta cos theta. Okay, sine 2 theta equals to 2 sine theta cos theta, and cos 2 theta, whereas you have 2 cos theta square minus 1, or 1 minus 2 sine theta square, and cos theta square minus sine theta square. Okay, so you have 3 cos theta, double angle formula, so you should know which one to use. Okay, even if you're not sure, try one by one and then see how it works. Okay, show that the modulus of z is 2 cos theta and the argument of z is theta. So first of all, to start with, z equals to square root of x square plus y square. Okay, this is the modulus formula. Okay, basically is the magnitude, okay, using the Pythagoras formula. So we know from here that 1 plus cos 2 theta represents the real value, and then I sine 2 theta represents the imaginary value, and imaginary values are the y-axis, and 1 plus cos 2 theta, which is the real value, represents the x-axis. So we can sub here 1 plus cos 2 theta square and then plus I sine 2 theta or sine 2 theta, and then we square that. Okay, we can discard the I. Okay, so now from there we get 1 plus 2 cos 2 theta. Okay, this is 1 plus cos 2 theta times by 1 plus cos 2 theta. Okay, so what you have is 1 plus 2 cos 2 theta and then plus cos 2 theta square. Okay, and then plus sine 2 theta square. Alright, so remember, 1 plus cos 2 theta is the x value and sine 2 theta is the y value. Okay, now let's simplify this further. Looks like cos 2 theta and sine 2 theta is going to give us positive 1. Okay, using the identity. So 1 plus 2 cos 2 theta plus 1, and this is same as 2 plus 2 cos 2 theta. Okay, 2 plus 2 cos 2 theta. Now change cos 2 theta with one of this double angle identity. Okay, I'm not going to take anything with sine. Okay, why? This is already with cos and we have already simplified here by using the identity, so I don't want any more signs. I'm going to just keep it with cos, so therefore I'm going to take the first identity. Okay, double angle identity. So 2 plus 2 bracket 2 cos theta square minus 1 close bracket, and this should give us, when you expand, is 2 plus 4 cos theta square minus 2 square root, and what's left, this 2 and 2 will gets cancelled. Okay, and what's left here is square root of 4 theta square, and square root of 4 is 2, and square root of cos theta square is 2 cos theta. Okay, so from there we get z equal to 2 cos theta. Okay, now find the argument of z, which is 2 cos theta. Argument of z is inverse tangent of y over x, and this is same as inverse tangent sine y over x. Y is sine 2 theta over 1 plus cos 2 theta. Sine 2 theta over 1 plus cos 2 theta. Now sine 2 theta is 2 sine theta cos theta over 1 plus, I'm going to use the double angle, 1 plus 2 cos theta square minus 1. So simplify this further. You have, that's 1 and 1 is gone, so 2 sine theta cos theta over 2 cos theta square, and this is inverse tangent, so that's what's left here is the top cos theta divided by the bottom. Okay, numerator and denominator gets cancelled, and that leaves us with 1 cos theta at the numerator, okay, as a numerator, so 2 cos theta, and you can see that this is tangent, inverse tangent of tangent theta, inverse tangent of tangent theta. Okay, so what is inverse tangent of tangent theta? Okay, so it's basically theta. This is same as inverse tangent 45. Okay, tangent 45 is 1, so inverse tangent of 1 is 45. Okay, so same thing, we apply the same maths concept here. So based on that, we get argument z as theta. Okay, next question. Prove that the real part of 1 over z is constant. Prove that the real part of 1 over z is constant. Okay, so I'll change color. Okay, part B. Prove that the real part of 1 over z is constant. Okay, 1 over z equals to, first of all, what's z? Z is 1 plus cos 2 theta, so it's 1 over 1 plus cos 2 theta and plus I sine 2 theta. Okay, therefore, okay, to approach this question, what I'm going to do, I'm going to multiply with the conjugate of the denominator. So if I multiply by the conjugate, I get 1 plus cos 2 theta. Remember, 1 plus cos 2 theta represents the x value or the real value, so that's one term, and then minus the imaginary, which is I sine 2 theta. Okay, so you do the same thing to the top, 1 plus cos 2 theta minus I sine 2 theta. Okay, so expand this further, so you have 1 plus cos 2 theta minus I sine 2 theta over, so this is 1 times 1 is 1, and then 1 times 2 cos theta is cos 2 theta, and then 1 times 2, so you have 2 cos 2 theta plus cos 2 theta square minus I square sin 2 theta square at the bottom. Okay, now 1 plus cos 2 theta minus I sin 2 theta over, okay, let's try to simplify. So I have cos 2 theta square plus, okay, I square is -1, so -1, so this is -1, so -1 times by negative gives you positive sin 2 theta square plus 1 plus 2 cos 2 theta, or 2 cos 2 theta plus 1. Okay, now let's simplify further. So you have 1 plus cos 2 theta minus I sin 2 theta over, okay, this will give us 1, so that's using the identity, so that's 1 plus 1 plus 2 cos 2 theta, so that will give us 1 plus cos 2 theta minus I sin 2 theta over 2 plus 2 cos 2 theta. This one, if I simplify, what do I get? Okay, I can break this 1 plus cos 2 theta over 2 plus 2 cos 2 theta minus I sin 2 theta over 2 plus 2 cos 2 theta, and this is same as 1 plus cos 2 theta over 2 1 plus cos 2 theta, so this 2 gets cancelled, and then minus I sin 2 theta over 2 plus 2 cos 2 theta, so therefore that's 1 over 2 minus I sin 2 theta over 2 1 plus cos 2 theta. Okay, so therefore the question says, okay, what the question requires, prove that the real part of 1 over z is constant. Okay, yes, you can see that 1 over z, which is the real part of 1 over z equals to 1 over 2 is constant. Okay.